Hi everyone, my name is Shah and this is the lab part of plain reinforced concrete 2 for undergrad batch 17 section A, B and C. In today's lab, we will learn how to determine the rupture modulus and the flexure elastic modulus of beam. So we will test different beams such as PCC beam, singly reinforced beam and doubly reinforced beam in center point loading method to determine the flexure elastic modulus and the flexure strength of these beams, and then we compare the result of all three beams. So the procedure of this experiment is covered in ASTM C78. So here we can see that we have to place the simple PCC beam in flexure testing machine. So first we have to measure the center to center distance between the span which is around 700 mm. Then we have to measure the height of beam which is 150 mm, and then width of beam that is also 150 mm, and we also fix a dial gauge. Here you can see he fixed the dial gauge at the center to measure the deflection at the center point. The maximum deflection of this beam will be used to determine the flexure elastic modulus. So now what we have to do, we have to start this experiment. So this is the software interface of the flexure testing machine. So here we select the option of flexure. Then we will give the name to this test like batch 17. We will set the loading rate. So in case of flexure test, the loading rate is 0.025 megapascal per second. So there is no need to change it. And then we have to give the dimension of beam. So here we can see that the width of the beam is 150 mm, height is 150 mm, and the lower span, which is the center to center distance between the support of a beam, is 700 mm, and the upper span is the distance between from the center of support to the load. This is the distance between from here exactly from center of a load to the center of support. So this is the upper span, which is 300 mm. So now we will start this experiment. So here we can see that you will observe the simple PCC beam failure, that its failure will be brittle as compared to the failure of singly reinforced beam and doubly reinforced beam. We have to measure the load versus deflection gauge rate at certain fixed interval. The reading of this experiment's load versus deflection reading and the failure flexure load will be provided you in Excel sheet for all the three beams to analyze those results. So we can clearly see the failure of simple PCC beam in flexure. And now we will note the failure load, which is 13.3 kilonewton, and the flexure strength is 2.37 megapascal. Okay, so now we place the singly reinforced beam. First, we have in the same procedure, we first measure the center to center distance between the support, which is 1400 mm. Then we will measure the height, which is 150 mm. Then width of the beam, which is also 150 mm. Now we will put all this data in software and then we will start the test. This is 1400 and upper span is 700, which is a distance between from the center of support to the load point. And now we will start the test. So here you can see the pattern of failure, the cracks generation which start from the bottom and moving toward upward. And also you can see the deflection gauge is also recording the data of deflection at the center point. So you can see that in case of PCC beam the failure was abrupt, but here you can see the cracks start from bottom and it slowly moves upward because this is due to the introduction of reinforcement. The reinforcement is playing its role. And here we can see the beam is failed in flexure, and we can note the maximum failure load, which is 17 kilonewton, and the maximum flexure strength is 5.328 megapascal. So in the same fashion we will test the doubly reinforced beam, and then we have to compare the result of all three beams. So all the data, I will provide all the data of load versus deformation at the center point of all the three beam and the maximum failure load, and then you will carry out the necessary calculation using center loading formula for flexure test to determine the flexure strength theoretically. So that's all from my side. Thank you so much. Allah Hafiz.